Welcome to The Explainer, where we break down the big topics. And today, we are looking at the absolutely incredible rise of humanoid robots. These aren't just science fiction anymore. They are stepping right into our world, and they're kicking off a whole new technological revolution. Alright, so here's how we're going to break this down. First, we'll meet the main players in this new race. Then, we'll look at the just staggering amount of money pouring into the space. After that, we'll get into the weeds on the huge technical challenges, building a brain, building hands, and we'll wrap it all up by asking the big question: what does this all mean for us, for our future? Okay, first up, let's meet the contenders in this new tech showdown. And I want you to remember, these aren't just a bunch of similar machines. Nope, they represent totally different ways of thinking about how we build our robotic future. So on one side, you've got the absolute powerhouse, Atlas. This thing was basically born from US Defense Labs. It's built with military-grade precision, a literal titan of titanium and AI, designed for the really heavy-duty work. But then on the other side, you've got the Unitree G1. It's nimble, it's agile, and, get this, it's astonishingly cheap. I mean, we're talking just $16,000. It is a true disruption engine built from the ground up for the mass market, for accessibility. This quote really nails it. It perfectly frames its whole competition. It's not just a simple rivalry, right? It's not just Atlas versus G1. It's about two completely different philosophies clashing. You've got that top-down, industrial strength approach versus the bottom-up, agile, innovative way of doing things. And the wild part is, they're both pushing the entire field forward at this incredible speed. And of course, you can't have this conversation without talking about the third major player, Tesla's Optimus. Elon Musk is aiming for low-volume production in 2025, and his vision is, well, typically ambitious. He wants a general-purpose robot that could be working on a factory floor one day and then helping out in your home the next. So, the big question is, why now? Why is all of this happening at this exact moment? Well, let me tell you, this is not just some cool science project anymore. It has turned into a massive economic gold rush, and it's being fueled by some really powerful global trends. The market is projected to just absolutely explode. Seriously, we're talking about a leap from about $1.4 billion back in 2022 to nearly $40 billion by the end of this decade. That is a scale of growth you almost never see in any industry. And this chart, wow, it really puts that growth into perspective, doesn't it? We are looking at a compound annual growth rate of over 52%. That is not a gradual climb, folks. That is a vertical takeoff for the entire industry. It's a rocket ship. So where are all these robots actually going to be used? It's a great question. We hear a lot about industrial uses, factories and stuff. But here's the interesting part. It's personal assistance and caregiving that's expected to be the single biggest driver for this market. We're talking over a third of the entire demand. And here is exactly why that is. We are right in the middle of a massive global demographic shift. The world's population is aging, and that's creating this huge and growing demand for assistance and for care. And that is a role that humanoid robots are, frankly, uniquely positioned to fill. Right, but to do any of this, a robot needs a brain, a really good one. And what we're seeing right now is a fundamental shift, a move away from robots that are just programmed to do things, towards robots that can actually think. Think about it. We've gone from these simple, pre-programmed machines that just blindly repeat the same task over and over, to robots that can see and react to what's around them. But now we are entering the real game-changing era, the era of what's called embodied intelligence. And this concept is absolutely key. Embodied intelligence. We're not just talking about some AI brain sitting in the cloud crunching data. No, this is about intelligence that's grounded in a physical body. It's about learning and reasoning by actually doing things, by interacting with our messy, unpredictable, real world. Okay, but here's the catch. There's a huge gap between the dream and the reality. Even the most advanced robots you see doing these amazing things, they're still basically just following a very, very detailed script written by human engineers. So the real question is, how do we get them to think for themselves? How do they learn to write their own script on the fly? Well, to solve that exact problem, researchers are developing completely new AI architectures. Now, a diagram like this looks incredibly complex, I know, but the core idea behind it is actually pretty simple. Think of it like giving the robot an inner monologue, a stream of consciousness. This lets it think through new situations all on its own and essentially write its own code in real time to adapt to whatever the world throws at it. Okay, so even if you have a brilliant brain, a robot is pretty useless without hands that can skillfully interact with the world. And honestly, this might be an even bigger challenge than the brain. I mean, think about this. Why is folding a simple t-shirt considered a huge milestone for a robot? It seems so easy to us, right? But for a robot, it is a monumental achievement. The challenge of just seeing, understanding, and then manipulating something soft and floppy and unpredictable like a piece of cloth is just immense. That is precisely why that demo of Tesla's Optimus folding a shirt was such a big deal. It's like the classic final exam for advanced dexterity. Seriously, the human hand is an absolute marvel of engineering. Trying to recreate its sensitivity, its strength, its dexterity, it is one of the toughest problems in all of robotics. You have dozens of joints moving at once, you have complex physics every time you touch something, and you need to be able to handle everything from a heavy power tool to a delicate piece of fruit without crushing it. So, when you get right down to it, mastering the hand isn't just a small detail. It's not an afterthought. It is one of the final frontiers. It is the pivotal challenge that separates a clumsy machine from a robot that can actually be useful in our world. Okay, let's bring this all home. We've met the players, we've seen the explosive market, and we've looked at the monumental challenges of building a brain and building hands. So, what does the future actually look like? Where is all this heading? This table does a great job of breaking down the two competing philosophies that are shaping that very future. On one side, you've got Atlas, the top-down, heavy-duty industrial titan, and on the other, you've got G1, the bottom-up, lightweight, agile disruptor. Each one represents a totally different but equally important path forward. And in the middle of all this, Tesla is carving out its own, really fascinating third path. Optimus is basically an attempt to merge these two different worlds, to try and combine the industrial strength and utility of a machine like Atlas with the mass-market accessibility and learning smarts of a disruptor like G1. And all of this leaves us with the ultimate question, doesn't it? As these incredible machines finally step out of the research labs and into our factories, our hospitals, and maybe even our homes, what role are they really going to play in our lives? Will they be our colleagues, our carers, or our competitors? The dawn of the humanoids is officially here. And now it's up to us to figure out what that really means.